Hey guys, this is Ron. So this is second part of our OSPF series. And in the first part, we configured Area 0, our backbone area. So routers 1, 2, 3, 4, and 5 are all configured for OSPF Area 0. They have built their neighbor relationships, they have negotiated DR-BDR elections, and they all agree on what the network looks like. Now in this video, we're going to bring in areas 1. We're going to configure up area 1 as a stub area. But we're also going to look at building a summary address for this 172 network. And then if we get time, we'll also start configuration of area 2 and we'll see where we get. So let's bring up our routers here. And just to validate that everything is still the way it was, we'll do a show IP OSPF neighbor on router 1. Router 1 has its two neighbor relationships with routers 2 and 3. They're full relationships. If I do a show IP OSPF database, I'll see that router 1 is aware of the router 1, router 2, router 3, router 4, and router 5 for our type 1 router link state announcements. And this again is all in area 0. It's also aware of each of the links hanging off of those different segments. So the advertising router in our case is the DR for those links. So router 2 being the DR between routers 1 and router 2 made an advertisement for that network. Router 1 being the DR between routers 1 and 3 sent out an advertisement for this network, so on and so forth. So that's the database so far. It only has area 0 in it, and it just has a type 1 router and a type 2 network. So to get our area 1 up and running, let's jump to router 4, and we'll enable OSPF area 1 on our serial interface. And again, I like to bring up OSPF on the actual interface. That way when I do a show IP protocols, it shows up as the interface there. I tend to prefer that. But again, you could do the network statement under router OSPF. But here we'll just do an IP OSPF 1 because we're using process ID 1. And we'll set this to area 1. Alright, so now if I do show IP protocols, I am now routing for area 0 on my loopback and fast ether interface. And for area 1, I'm advertising for on my serial interface. Okay? So let's go ahead and jump to router 6, which is also in area 1. So we'll set up router OSPF process ID 1. IP OSPF process ID 1, area 1. And we are now exchanged, and we're all the way up to full. Now I did want to note this. If I could put a space in there. Third time's a charm. Prior, when we looked at under our interface, we saw that OSPF network type was a broadcast, and that was because we were on an Ethernet link. Now that we're on a serial link, this is a point-to-point link. And what we don't see in here is any reference to DR-BDRs, again, because this is a point-to-point link. It's not a multi-access broadcast link like we saw before. And so there's no point in electing a DR or a BDR because there's only ever going to be 2 hosts on this network. Now notice our hello and dead timers are the same, but again, we could adjust that if we had cause to, but in our case, we're going to leave it alone. Our router ID is our loopback address, and we've built an adjacency with router 4. Okay. So we have a neighbor relationship with router 4. There's no sense in having a priority because, again, there's going to be no BR or DR or BDR election. We have a full relationship. There's no DR, no BDR, and so we're good to go. Okay, so here's my understanding of the database from the perspective of router 6. Now notice I only know about router 4 and router 6. Again, because between areas, I'm not going to send those DRs. Okay, I only need to know about my specific network or network devices within my area. I'm only running area 1. Now also notice, instead of getting a network LSA, I have a summary LSA. And again, this is because these are different advertisements coming from a different area. And so what I get is a summary from an ABR. So we talked about an area border router sits between two areas. And so my link to the outside world, it has to go through router 4. So router 4 is the advertiser of all of these summary networks. So I have that network between routers 1 and router 2, router 1 and router 3, so on and so forth. But they're all being advertised from router 4 because router 4 is the ABR that I have to go through to get from area 1 to whatever area holds these different networks. Okay? And if we look on router 1, I have my original routers, I have my original networks, but now I also get a summary for this network between routers 4 and router 6, and it's being advertised from router 4 because router 4 is the ABR between routers between area 0 and whatever area this network lies on. Okay? So we're seeing how some of the LSA types come into play here. Now if I come back to router 6, we talked about, if I minimize this, about all of these extra networks. And I want to advertise them into the rest of the network. So let's go ahead and set that up. Now let's see if I actually remembered to configure them. Most likely I did not. So interface L1. IP address, we'll call this, we'll just do it as 0.1. We'll do L2. And I apologize for not having this already configured. L3. And L4. Alright, so now we have each of our addresses there, and we'll go ahead and put those in our area. So interface L1, IP OSPF 1, area 1, 2, 3, and 4. Alright, so now we're routing on interfaces connected explicitly to area 1 for loopback 1, 2, 3, and 4. So what I should see here in my routing table, I have entries for each of those different networks. Also notice here to the side, I have an IA. So under, if I do a show IP route, and I actually get my header here, it's going to say, and capital IA should be an inter area. If I could read, there it is. So IA is an OSPF inter area. All right. So I know right off the bat that this route is being advertised in OSPF, but is in a different area than what I'm in, right? I also see it for the 4.6 network, which is between routers 4 and 6. So this is all within that area 1, all right? What I should see is I have additional network statements under my summary LSA type. And so I can do that. Now, if I wanted to, instead of having this go out as 4 different advertisements, I can shrink it down. So the way that I'm going to do that is, who is the appropriate router to make that advertisement? Now, it might seem like it should be appropriately advertised from R6, because R6 contains these networks. So it should be the one, instead of sending out 4 advertisements, it should be sending out 1 advertisement. However, within OSPF, the only way that you can create a summary address is on an ABR. So because this R4 sits in between the 2 networks, it's the right router to make the advertisement for that summary address into another area. And so we're going to have to configure that summary address on R4. So if we go to R4, we'll go under router OSPF1, and we'll do area 1, and we can do a, let's see here. No. Oh, it's right there. I just can't read. I'm like looking at all these and I'm just like, oh, it's not in there. Where did it go? Again, it notes here this is border routers only. So this is our ABR, because we're going to summarize routes matching a certain network statement. So we'll do range, and we'll do 172.16.0.0, and we can do a mask. Should be something like 252.0, and hopefully I got that right. So we'll see. If I do a show IP OSPF database again, I now have an advertisement for the 00 network. Its age is 9 in here. So I still have my original addresses, and hopefully those would eventually fall off. But more importantly, let's look in my actual router. So show IP route OSPF. And now instead of having 4 different network statements, I now have a single network statement that will cover the whole 172.16.0.0 network. Okay? And it is a /22. So that makes sense, right? So if I do or I don't even need it, ping 172.16.1.1, and I can hit it. All right. So good to go. So there we created area 1, and then from area 1 we added these additional network statements in, and we created a summary address for those various networks on our area border router, and we sent those out into area 0. Okay? So the last thing we'll want to do is create a stub area. So stub area does a couple different things. It can reduce the number of basically the size of our routing table if we would like. It can reduce the size of our database if we would like. Again, we're just trying to build some efficiencies. Now, the stub here makes sense because from router 6's perspective, it only has a single way in and out of this area. And so making this a stub makes sense, as opposed to if we had another link out here that could possibly get us back to here, we wouldn't necessarily want to make this a stub, because now it might become some type of transit for another area, and that would cause real issues. But in our case, we have a single link out of area 1, so it makes sense to make area 1 a stub. Now, stub networks have to, both devices within area 1 here need to agree that area 1 is a stub. If we tell router 4 that area 1 is a stub, but we don't necessarily tell router 6, we're going to have some issues. And so we'll want to make sure we configure it on both of our devices here. So under router OSPF 1, which we were already under, we're going to do area 1 stub. And we could do a NoSummary, which we'll set here in a second. But for now, we're just going to create it as a stub network. And so there's an adjacency change because we made a change to the way area 1 is set up. We'll go back to 6. And we'll also tell it it's a stub. There is an adjacency change, and we go back to full. All right, so our routing table doesn't look all that much different than it did before. We still know about all of the different networks that we knew about before. We know about the various routers within area 1. But notice here, we have a quad 0 route. The quad 0 route, well, that is a default route. So now what we're saying is that within area 1, there is a default route that says to get out of area 1, go to router 4. And if I do show IP route, I do in fact see that. So I now have a default route which says go ahead and go to router 4 in order to get out of the network. But I still have my full routing table that I had before. But I do have an inner area route of a default saying go to router 4. Okay? Now, one of the other things that I can do is I can tell it a NoSummary route, right? So if I go back here and I look here, I have all of these summary LSA types being advertised into my router on area 1. So what we're telling it is I don't care about any of these networks because I know I at least have a default, and that should be the way out of the network. So let's do that. So area 1, and hopefully I'm not going to have to reset OSPF, but we'll see. Area 1 stub, NoSummary. Area 1 stub, NoSummary. Now notice here I didn't see a force of a reset. So let's go here and see if it actually changed anything. So do show IP OSPF database. But it did change. So notice here in my summaries, I no longer have all of those other networks from area 0. And if I do show IP route, my table is a whole lot smaller than it was before. I have my connected routes, and I have a single route under OSPF that's my default route to get out. And so if this were an underpowered router that for whatever reason there's a whole lot of extra networks out here, and I didn't want to waste the power on this router to understand all of those when it only has a single route out of the network, I can create a stub area, or I can further create a stub area NoSummary And so all I have is the default route out of my network. And so this becomes hyper efficient for router 6. Okay. Now, because we created it as a NoSummary, did we lose our advertisements out of this network? Let's find out. Let's show IP OSPF database. Notice here, we still get our summaries, and our summaries is for that 172 network and our 46 network. So notice those other ones finally dropped off. I still have my inner area route for the 172 network. I still have my inner area route for the 46 network. And so you see that we're still getting our advertisements out of area 1, but inside of area 1, we're hyper efficient because, again, I only need this default route to get out of area 1. And so we've made this, like I said, hyper efficient. So that should be about it for part 2. We've gone about 20 minutes. We've set up area 1 here. We created it as a stub. We've created it as a stub NoSummary. We've sent extra networks across into area 0. We created summary addresses for that network. And then we looked at how those router network net summary addresses come into play as you're crossing these OSPF areas. So again, I hope you found this helpful, and I look forward to doing part 3. Thanks for watching.